CYU3, or if you finished it already, congratulations. So the first one is asking you basically if it's a function, and you can use a vertical line test, right? And let's see, there's a tool here. You can take a straight line. Oops, maybe not. Let's see if I can do it another way. Yes, there, I can use that. So let me take a straight line, right? And then let me erase this stuff out. And if you use the vertical line test and you move this through the graph A, you notice that our line, our vertical line, touches that graph into 2 points here and here, so that one fails the vertical line test. Therefore, it's not. Second one, C, also fails the vertical line test. It's obvious. B fails the vertical line test, right? Over here. And then D is the only one where our line, the vertical line, meets the line on the graph in only one particular point. So D is the only one that is correct. So let's click on D. D. I'll show you thinking. So I ask you, so this one you can draw that submit. Let's see if I'm correct. Yep. Number 2, so you're able to drag that, and I just don't know how to make it bigger, but it's asking, basically saying which one should I remove in order to keep this as a function. So -3 and 3, the first one, well, -3 and 3, so if you look at the set of pairs over here, -3 and 3, there's only one -3. There's only one x value that's -3, and this, so removing it really doesn't make any difference. So 4 and 2, and again, there's only one x value that has a value of 4. So removing that, it's not it. -2 and -1. So if you look at -2 and -1, I have one order pair that's -2 and -1, and I have another one where it says -2 and -3. One of these two has to be removed because you can't have two x values, right? The same two. So if you did a mapping diagram, mapping that, it would look like this. -2 goes to -1, and -2 also going to -3. So sometimes it's easier if you see it this way. So -2 is going to -1 and -3, and that is not aligned because every input should only have one output. So by removing this, if I took that out of the set there, it would make the relation of functions. So we want to say that. Let's remove -2 and -1. Each table represents blah, blah, which table does not represent a function? Well, same thing as the previous question. So let's see if I can drag this, and I wish I knew how to make that bigger. Maybe I can't. Oh, there you go. And he learned. Let's look at the first one. 0, which is, what's the question? Which is not a function, okay? First one is a function because every x value has one y value. B, let's look at B. 3 goes, B is okay. C is okay, but D is an issue. And then I'm going to draw this because sometimes. So D, we have an input of 3, right? And the output is 0, 1, 2, and 3. So notice that the x value 3 has 4 different outputs, and that's not allowed, which makes D our table that is not a function. Which graph does not represent a function again, so we can again do that vertical line test. Oh, we kept. So if I drag this, so A is definitely a function, right? B is definitely a function. Look, right? There's only one point of contact, one point of intersection. D is definitely a function, right? But C is going to fail because when I go right here, notice that we're going to have 2 points of contact. One is going to be right here, and the other one right here. So C is the one that is not a function. Again, we can draw a line right here, right, showing that for the x value of 1, we have a y value of 1 and 3. here we have x, and x is 1. We have x being, 1, and x being 3. And because of that, it's not a function. For the table and the graph show which one has a greater rate of change. So all you have to do is find the slope. And let's find the slope for function A. So for function A, let's find the slope. And let's cut some corners here. So from 5 to 7 is plus 2. From 2 to 1 is 1. So the slope would be 2 over 1, or just 2. So the slope for function A is 2. The slope for function B, and we're going to take any 2 points, look at the y, right? The change in y values. So slope is change in y values over change in x values. Let's look at the change in y values. From 4 to 1 is 3, and then from 1 to 2 is just 1. So the slope is positive 3. Which one has the greater function? It'd be function B. 6. What do we want to do with 6? The equation y equals 4x plus 2. They're saying that the equation y equals 4x plus 2 is, the equation for this, is that true? The rate of change of function, wait a second. Oh, there's a table, and this is function g, I'm sorry. This is function g, and this is function f. And we're going to compare the statements, rate of change. So we need to find the rate of change for function f. So from 18 to 24 is 6, from 4 to 6 is 2. Right? So we got change in y is 6, the change in x is 2, and the slope is 3. So let's see. Rate of change of g is less. That's not true. The rate of change of g is less than the function change of f. That's not true because g is greater than f. The rate of change of g is less. No, the rate of change of g. What? Did I do something wrong here? 24 minus 18, that's 6. 6 divided by 2 is 3. The rate change of g is less than the rate of change of f. No, the rate of change of g is less than the rate of change of f. No, the rate of change of g is less than the rate of change of f, because what in the world is going on? The rate of change of g is less than the rate of change of f because 4 is greater than 3. This is 6, so let me try again. That's 6 and 6, that's 12. This is 4, so the slope is 3. I don't understand why, unless I'm reading this wrong. That's f, and this is g. Which statement is true? The rate of change of g is greater, though. I don't know what am I missing? The rate of change of g is less. No. The rate of change of g is less than the rate of change of f. No. The rate of change of g is less than the rate of change of f. No. Skip. If you have the answer, let me know. I don't think any of them make sense. 7. 2 equations shown below. Identify each as function as linear or nonlinear. Okay. So first of all, they're linear. They are both. What the heck? State a reason why function. State each function as linear or nonlinear. Okay. So function p is not linear. I don't know how they want. So function p nonlinear. Right, I'm not going to press any button. Function q is linear. Right, so if you look at the variable here, x is the negative first power, and we said it had to be positive 1 in order to be linear, and function q has 1/3 x, and x has a exponent of 1. So state right, function q is linear. Okay, function q is linear. 8. Which equation represents a linear? Well, look at again at the variables. Look at x, right? At x, and it has to be x to the first power. So 1 is good. 2, or the second one, is x squared, so that doesn't count. Third one is x squared, and the fourth one is x to the cube. So the only one that has x to the first power is that one. Which scatter plot best represents a linear association between, so linear. So the easiest way is to draw a line of best fit. So this would mean, this would be exponential. This would be quadratic. This would be no association. And this would be the closest one to linear, right? There's a negative linear relationship. So I'd say D. Scatter plot below shows something, the average number of customers who visit a food truck. Okay, so what's the best, which statement best describes the association between the number of days? Okay, so it's looks like the longer the the food truck stays in one spot, the more customers. Why? Because they're used to that spot, right? They know that he's going to be there all the time. As opposed, if you keep moving around, you might lose customers because now you don't know where you are. They don't know where you are. So this is a definitely positive and linear association. Okay, so this one is pretty easy. You draw a line of the best fit, definitely straight line here, and it's negative, so there's a negative linear association with no, are there any outliers here? I mean, if you had seen an outlier, it'd be a dot that's somewhere like that, for example. That guy would be an outlier, but I don't see any outliers. So I'm going to say this is negative with no outliers. And 12, you have a scatter plot. And it's points scored and points allowed. Oh my God. Is there association here? I don't see any. It looks like all over. I can't make a straight line on this, whether positive or negative. It doesn't seem like I can draw a line of best fit. Which association? No association, positive, negative, non-linear association. I'm just going to go A. No association at all. So you're thinking, because there is no relationship between x and y values. I don't see, as x increases, the y increase, as x decreases, the y increase, or vice versa. No, so there's no relation. Shoe size and the heights of classmates. Okay, along which scatter plot shows the best accurate line of best fit. So remember what I said, line of best fit should go through the middle, right, where after you draw the line of best fit, you should have sort of the same amount of data points above the line and below the line. A is definitely not it, because look, all the points are under the line. B is also not it, because a lot of the points are under the line. There should be some above it, so that's garbage. And so A, B, and D, they all follow the same path. The only one that looks really good is C. And you notice that after you draw the line of the fifth, you have some points above the line, some points below the line. 14. What is the question? Oh no. Line K is the line of best fit. Okay, so again, the data shows strong linear association, which scatter plot best has the line of best fit. Okay, so look at A. It's obvious it's not A. That's not even close to being a line of best fit. So that's not it. C as well, because all the values are above the line. No. Now between B and D, actually, B and D pretty look okay. Best represents the data like K. So what are we talking about first of all? It doesn't give us a context and story-wise. Ugh. I like D. Let's see what that says. Oh, look at that. 15. Oh, two-way tables. How many students in Class B got in Class B? Class X got a B. In Class X, 12 people got a B. It's just a matter of reading. Complete the two-way table. Okay. Is there anyone with only one data missing? So if you look here, everything is filled in except this one. So we can actually find. So it'd be 29 minus 15 and minus 3 and minus 0. 29 minus 18, which make this guy 11. We can now take advantage of that and find this guy here. The total for the 60 to 75 second. 19 plus 1 is 20, plus 11 is 39. But whenever you have only one data missing, you can figure it out. So here is 31 plus 21, which is 52. 52 plus 3 is 55, which would make this guy 45. Now I can go back and do this one. 15 and 10 is 25. 25 and 6 is 31, which makes this guy 14. And slowly I can fill in the rest. Let's do an easy one here. The total here in 12th grade should be 16. I have 6, 2, which is 8. So this makes this guy 8. We can do this one across. 35 plus 29 plus 16. What is that? 11, 20 goes 2, 5, 6, 7, 8. That's 80, which makes this 20. And now we know the total in 11th grade has to be 20. We have 8, 10, 18, 19, which makes this as a 1. On the 9th grade, we should have a total of 35. So far, I have 19 and 14, which is 33, plus 2, 35, which makes this a 0. The question is, what percentage of 9th graders recorded 55 to 59? The answer is not for 15. That's just for, 14. They're asking for percentage, so you actually had to say 14 out of 35. That's the same thing as asking, hey, you had a quiz, 35 questions, and you got 14 correct. What was your grade? So if you put 14 out of 35 on your test, on your calculator, you get 0.4. Remember, you have to multiply that by 100, and that gives you 40%. And that's what we're going to enter here, 40%. Submit. 17. The graph shows a linear relation. What is the slope? So again, to find the slope, ladies and gentlemen, pick two very easy points, the easiest points you can. And I'm going to pick 0, 0. And I pick another one, 1 and 2, right there. Find the slope. So find the slope, y2 minus y1, x2 over x1. So if you did that, you would get 2 minus 0, 1 minus 0, which gives us is 2. So the slope is 2. We have the graph, and then we have 4 equations. Which one represents this? Well, first of all, the first thing you should look at is the y-intercept. So the y-intercept is right here, a positive 1, right here. So here's the y-intercept. So this guy goes, this one, not point, this one is garbage, this one is garbage, because both of them have the slope as -1. So please don't even consider them. So it's just a matter of either it's 2x plus 1 or x plus 1. Oh, you have 2 points. Right, 1 point is 3 and 4, and the other point is 1, 2. So if you wanted to just count the units, you can do that, or just do the slope. So we're going to do y2 minus y1, so we end up getting 4 minus 2, 3 minus 1. 4 minus 2 is 2, 3 minus 1 is 2, which gives me the slope of 1. So B, right there, remember there's a 1 in front of the x, so that has a slope of 1 and the y-intercept of 1, which is what we're looking for. What's write the equation? So we want the equation of this line. What is the y-intercept? So thankfully, we can see that the y-intercept. So we have y equals mx plus b. I already know that b is 3. Now I just got to find the slope. To find the slope, I take 2 points. So let's use that point. That point is 0, 3. Let me get one more point right here. 1 and 0, 1. Sorry, not 0, 1. 1, 0. So let's do y2 minus y1 and all that stuff. I get 3 minus 0, which is 3. 0 minus 1, which is negative 1. 3 divided by negative 1 is negative 3. So there's my slope. So now I gotta plug it in here. Y equals negative 3x plus 3. Right? Let's see if that works. Y equals negative 3x plus 3. Yay. Write again the slope, write an equation for this. So again, anytime you're doing this, see if you can if you can see the slope, right? So if you can, not slope, the y-intercept. But that's half the battle. Notice that the y-intercept here is a pain because it's right here, and I don't know what that point is. It's right in the middle. I'm not gonna assume it's 1.5. So we're gonna have to do this the long way. So let's pick 2 points that are on the graph. Let's pick this guy right here and this guy right here. So 1 point, 1 and 1. And the other point is 3 and 0. Yeah? So let's find slope. Slope is going to be 1 minus 0 over 1 minus 3, which is negative 2. So the slope is negative 1/2. Going to my equation, Esther. Thank you. So mx plus b, I have the slope negative 1/2 x, and then the plus b. We're going to pick a point, whichever point you want. And in this case, I will pick 1 and 1. So I'm using this point here to substitute. So 1 equals negative 1/2 times 1 plus b. 1 equals, let me put that in as negative 1/2 plus b. We're going to add 1/2 to both sides. And b is 1.5. Notice that we're close because that looks like 1.5. So the final equation is y equals negative 1/2 x plus, and I guess 3 over 2 is a slope. Or you can write it as 1.5. Alright, almost done. So this one, I know somebody brought it up and they're saying that the question, the program is not going to accept the answer, so let's just try it and then we'll write the answer. So the slope is 0. Remember, if it's a horizontal line, is 0. So we can start building our equation. Y equals 0x, because the slope is 0, remember, plus b. Is there a y-intercept? And there is, right here. And that point is negative 20. So y equals, and I'm not going to write 0x because that's just 0, but minus 20. And that's it. And, oh, look at that. It did accept. Huh. Wonder what happened. Great.